thank you all for coming to this talk. So I will be going to talk about the Prometheus Operator ecosystem. So just want to know how many of you have used Prometheus Operator before. So just little things about me. So my name is Jayapriya and I'm working as a senior software engineer at Red Hat OpenShift Monitoring team. I'm a contributor and member in the Prometheus Operator GitHub org. So you can find me in GitHub at /point. So these are the key takeaways you can expect from this talk. You will get to know how to configure and monitor the Kubernetes resources using Prometheus Operator, how the Prometheus Operator works and its available features, and also deploying the monitoring stack, how to do that, and also a couple of examples also you will get to see in the slides. So before starting about Prometheus Operator, just talk a little bit about Prometheus briefly. So Prometheus is an open source monitoring system and an alerting toolkit originally developed at SoundCloud, but it has been under CNCF since 2016 and it's a second project hosted after Kubernetes. So it's a metric based monitoring system which has a multi-dimensional data model which allows to store the time series data. It offers a lot of features, like it has an inbuilt query language called PromQL, and it doesn't rely on any distributed storage as well. If you have it on run it on a node, all the data will be stored in that respective node. It's a pull-based system, but it also has a push-based mechanism for the short-lived jobs using the push gateway. And another important feature is it has good service discovery mechanism, and you can also use the static config for the static targets as well. So this is the system architecture of the Prometheus. So in the center you can see the Prometheus server, which actually collects the matrices from the targets you have defined in the configuration. It could be static target or it could be dynamic targets like the services or pods in the Kubernetes. And all the data will be stored in the Prometheus TSDB, and which will be later evaluated for alerts. And once the alerts are evaluated and if there are any issues, then the alert manager will be notifying the admins or someone using the different receivers like a PagerDuty or Slack or any other webhook mechanism. And another thing is it can use to create various dashboards using Grafana or any other dashboarding utility, or even you can query in the Prometheus UI itself for like ad hoc debugging, or if you want to check something what's going on, something like that. So now let's move on to Prometheus Operator, today's topic. So this is the Prometheus Operator GitHub org. It has the main two projects. One is the Prometheus Operator itself, which actually is used to manage and deploy Prometheus, and kubeprometheus, which is an out-of-the-box monitoring stack you can deploy using it. So we are talking about Prometheus Operator. So why we need this project itself? So a typical monitoring stack will contain different components like Prometheus, AlertManager, Grafana, or Thanos, like that. You can configure these components yourself if you are risk-taking person, because these are very much error-prone, because you need to configure the YAMLs by yourself, or you have to check it if it is working or not, and you have to then configure various secret objects to have your secrets like some token or something like that, and you have to configure the persistent volumes and persistent volume claims to store the data persistently, and you have to then deploy these objects. And when you have this in production and something goes wrong, it's very difficult to revert as well. So this is one of the pain for system admins or SREs or whoever is trying to set up the monitoring in the Kubernetes. So how Prometheus Operator can help you here? So it is based on the Kubernetes custom resources. So it is a Kubernetes native way. You can declare what is the config needed for your Prometheus, and the operator will take care of deploying them. So it's like a simplified deployment configuration, you can say. And not only that, you can also define, okay, how many targets, which all targets to monitor, You just need to specify everything in the YAML format, and the operator can take care of rest of the things for you. So how Prometheus operator works? So before that, let's just a little bit about what is operator itself. So the operator pattern was introduced by CoreOS as a class of software which operates other software. So it is basically like the putting your operational knowledge collected by over the years or by humans into the softwares. So normally any admin or an SRE will know how to configure your application, how to deploy that, or if any issue comes, how to fix that. So we are putting all this information into a software, and we are letting the software take care all these things for you. So basically you can say operator is CRD plus custom controllers. So custom resource is an extension of Kubernetes API where you can store and retrieve structured data. Basically you are telling there, okay, what is the desired state of your application, and the custom controllers will be watching these custom resources and it can act upon them. So similar way like how you are defining a pod manifest, and the pod controller will take care of deploying the pod for you in the Kubernetes. But in case of custom application, the Kubernetes doesn't have the knowledge what your application is, how it should be responding to changes. For that we need to create a custom controller. So in short, you can say operators are software SREs. So this is just a high level architecture of the Prometheus operator. So as you can see in the middle, all you see is the CRDs available as part of the operator. So you have like Prometheus, Thanos ruler, and alert manager, which will form the stateful set in the end when you deploy using the operator. And those are the like alerting related and the monitoring related components like ServiceMonitor, PodMonitor, probe, and ScrapeConfig is used for creating the monitoring related configs like what to monitor and which all objects you need to monitor. And PrometheusRule is the object where you can define the alerting rules, and AlertManagerConfig is to define all your AlertManager related configs. And in the, on the right side you have the Prometheus operator controllers who will be actually watching these resources or any changes happen to that, and it will be deploying all the objects as a stateful set. So this is the same thing, like just put it as a like differentiation, like which all parts will be forming as a stateful set and which all are the config objects. The red ones which I highlighted are the new ones which we introduced recently. So one is the Prometheus Agent and one is ScrapeConfig. I will come to this later. So let's look at the first one, which is the main Prometheus resource. So here you can define what all things you need to configure for your Prometheus instance. For example, how many replicas you need to deploy, how many resources you need to allocate, which alert manager it should sending the alerts to, and there are also so many config selector fields available like ServiceMonitor, PodMonitor namespace selector, or PodMonitor selector, like that. So these are the selector fields which you can mention, okay, which all service monitor should be selected while I running the Prometheus. So this, and there are a lot of other fields which you can find in the documentation, or when you write kubectl explain the prometheus.spec, you can find that. So these are the main ones. But just forgot to mention, the one highlighted one is where you can say, okay, which are objects you need to monitor. So it can be like in the same namespace, or also it can be different namespaces as well. So in this example I have shown in the only the service monitor selector, so it will be checking in the same namespace which all services have the which all service monitor has the label like team front end. So there is also service namespace selector as well, service monitor namespace selector as well. There you can specify which all namespace labels to match. If nothing is specified for service monitor namespace selector, only the on namespace will be checked. And that means wherever the Prometheus is being deployed. So let's look at the collecting matrices, how we can do that. So as I explained earlier, there are 4 objects. So in this slide I have put only 3. I will come to the next one later. So ServiceMonitor, which is used to define how the group of services or services we can monitor. So this is how to select it based on label selector. And in case of PodMonitor, as the name says, it is used to select which all pods you can monitor with the help of this label selector. And next is last one is probe, which is to monitor static targets or ingress objects. So in order to do that, you should have a black box exporter installed in your system on the cluster, and we can use the label selector to define which all ingress objects which you need to monitor. So I have put some of the links which you can see for detailed examples, but I will have some of them in the slides as well. For example, this is one for ServiceMonitor. So on the left hand side you have a service object where you will have the labels. In this example I have a label like app.kubernetes.io/name Prometheus Example app, and in the ServiceMonitor the important field you can see is the selector field, where you are actually specifying match labels. So you are specifying, okay, this is the labels I need to watch for. So if there are more than one service having the same label matching, all those will be selected as well. And the next important one is the ports field. You have to specify what is the name of the port which you need to monitor. So this is one of the main issue we have found mostly in the GitHub issues. The people complain, okay, I cannot find my target in the targets page even though I configured my ServiceMonitor. So these are the main cause of some of the error prone issues. So just watch for this and you can see, okay, how when you see some issues when you face this will be the main one of the things you can go and check. Okay, so once I create the ServiceMonitor, the Prometheus operator will be taking all those details and putting into the Prometheus configuration. So you don't have to do any Prometheus related change, you are just creating an ServiceMonitor object and you can see those targets in our Prometheus UI target page. So all those, so using this is very easy, so that you don't have to worry, okay, any Prometheus related config language or something like that. So similarly PodMonitor also is similar, so that's why I did not put it in slide here. So instead of service, it will be looking for the pod. The next one is for probe. So like I said, we can use probe resource to monitor static targets as well as ingress. So in this example, it's for ingress, static target. So you can specify which are the static targets which you want to monitor. For example, you are just checking health, like, okay, my application is up or not. Is it so something like that. So in this example, I have just given some demo sites. So if you have this check, it will be keep on probing and checking if the site is up or not. So it's the same example. After you do that, you can see this in the target page. Next one is ingress. So similar to the other monitoring objects, here also everything is working on label selector. So whatever the namespace label you specify in the ingress, same you have to be specifying in the selector field in the probe for the ingress target. Okay. So what are the latest features we are having in operator? So AlertManagerConfig existed for some time and it's been moved to V1 beta 1 since 0.57, and Prometheus Agent, which was released a couple of months ago, so it is available from 0.64, and next is a ScrapeConfig. This is also available from 0.65, which is our latest release. So both of Prometheus Agent and ScrapeConfig is in V1 Alpha 1. So you cannot use this in production, but you can try it in your like dev or staging, and yeah, so it could be error prone, so please try it out. You can report any issues. So I will just explain why we needed the ScrapeConfig. So before having ScrapeConfig, we have already one feature available in the operator called additional ScrapeConfig. So using this, you can actually specify the Prometheus config, like, okay, the job name and the static configs or something like that, and you need to create a secret out of this YAML. So once you do that, and you have to specify the additional scrape configs in the Prometheus field. So the problem with this approach is that whatever you specify in the config field, you are on your own. Like there will be no kind of validation if any issue with your YAML or anything. Excuse me. So this ScrapeConfig CR, you can actually specify all this configuration the Kubernetes native way. So similar to PodMonitor, ServiceMonitor, the issue we faced is whatever field or any Prometheus configuration related field you add, same you have to add across different monitoring CRDs. Like if I have something like label value limit or something, I add in ServiceMonitor, I have to add the same thing in the PodMonitor Pro, like that. So this was actually cumbersome. So I think once we have this CRD graduated, we should be able to use ScrapeConfig directly, and we should be able to use it along with ServiceMonitor and PodMonitor, so that you just need to specify one ScrapeConfig and it is very easy to apply it across different objects. So in this example, actually I have given for the static configs actually. In the targets I have given an example of actually in cluster service, but you can replace it with using any of the external monitoring targets, like so something like node exporter running outside the Kubernetes cluster, so you can specify that in the target field. So this is one of the question which we used to get, okay, how you can monitor an external resource using the operator. So currently it supports file SD configs and static configs and HTTP SD configs. So there are still more to develop. So we currently is very limited. So you can just try it out, and you can also contribute so that we can have most of the features supported in the scrape configs. So this is the same which I explained. Like currently you can use ServiceMonitor, PodMonitor, and ScrapeConfig with only limited features. So then everything will be actually put into the Prometheus config itself. So later, once we have all the features developed for the ScrapeConfig, you should be just able to use the ScrapeConfig and define everything in ScrapeConfig, and maybe you can point it to the ServiceMonitor and PodMonitor, and the Prometheus config will be updated. Okay, so the next is Prometheus Agent. So this is one of the new feature in the Prometheus, available from 2.32 if I am not wrong. So this is for basically for optimized for RemoteWrite use case. For example, like edge use cases, you can use agent, which actually will consume lesser memory because it disables querying, alerting, local storage, and it replaces everything with a customized TSDB val as well. So everything else stays same, like scraping logic, discovery, and all other configs. But this is for people who don't want to use Prometheus for querying, but just to collect the metrics and send it to a different system. So this was also one of the long-awaited feature in Prometheus Operator. So in this way you can actually specify, it's similar to how you specify the Prometheus resource. The only difference would be like the kind will be Prometheus Agent, and the API version will be V1 Alpha 1. And you can specify similar to the Prometheus, you can also specify all the selector fields on what you need to monitor. Okay, so till now we talked about these various monitoring CRDs. So let's see how this monitoring works. So when a user creates these monitoring objects like ServiceMonitor or PodMonitor, the operator controller will be watching these resources. Okay, if somebody is created or somebody is updated, and based on that, it will be updating the secret object in the Prometheus config so that the new changes are being propagated to the Prometheus. And this secret will be actually watched by the config reloader sidecar, which is actually the how we deploy the Prometheus pod. So Prometheus pod will have Prometheus container as well as the config reloader sidecar. So this sidecar will be watching this secret in regular intervals, and it will be pulling the secret object and updating the volume so that Prometheus can get these updated configs. So till now we talk about how monitoring works. Now just move on to the alerting part. So we have all these matrices now. How to inform when something goes wrong? So there are two types of rules available in Prometheus. So one is recording and one is alerting rule. So recording rule, as the name say, it allows us to pre-compute any frequently used or any computationally expensive expression, so that if you need to check something, you can just go and query that particular metric. So this is quite useful for the dashboarding purpose, because you might need to refresh the dashboard in regular intervals as well. And alerting is like you can use it to create the rules which defines, okay, certain condition goes wrong and you should be alerting that to a system. So this is just an example. The first one is the alerting rule, where you specify the expression. Okay, in this case we are just using the HTTP request duration second, and you are specifying a condition. If something, if this expression is satisfied and is evaluated for a certain time, like 5 minutes here, you should be sending an alert. And in the second one, like Grafana rules mentioned there, that is an example for the recording rule. So the Grafana rules will be the name of the metric. So whenever you query Grafana rules, the result of this expression will be returned. So you don't have to memorize this like very long expressions. So this is also one of the thing I wanted to highlight. I think most people don't use the admission webhook, so you need to deploy this separately outside Prometheus operator. So it actually will help you to detect like invalid recording or alerting rules from causing failures. So sometimes you will be missing maybe some comma, or you may be putting a wrong expression over there. So in what happens is your rules will not be getting picked up by the Prometheus. So this will be difficult to identify, okay, why my rule is not picked up. So if you have an admission webhook, you can get the real-time feedback from the API server, okay, something is wrong on what I have defined. So it will help you to validate the Prometheus rule upon the creation or any updating. So you can check out in the GitHub user guide how to configure the admission webhook. So next is Alert Manager. So Alert Manager, like I said in the beginning, it is used to receive alerts from the Prometheus. So we can alert definitions, whatever has been defined when the Prometheus rule will be evaluated by the Prometheus and will be sending to the Alert Manager. So it supports deduplication so that we don't get multiple alerts for the same issue. And it also helps to aggregate the alerts, and also helps us to send the notification across different channels. So this is how the Alert Manager CRD will look like. So it also gets deployed as a stateful set, and we can have the configuration for the Alert Manager as well. So there are two ways to do that actually. One is using the Alert Manager secret, like you can define all the configs which you need for the Alert Manager in a secret, and that will be picked up by the Alert Manager object. Or you can use a AlertManagerConfig CRD. So it's connected to the Prometheus using the alerting.alertmanagers field. So there is a field in Prometheus spec like alerting. So inside that there is Alert Manager, and where you can specify which Alert Manager you need to pick up for your cluster, like this one. Okay, so like I said, there are two options available, either create it as a secret, or you can use an Alert Manager configuration. So that would be the Kubernetes native way, because you will have all the validation set up. But in case of you are using as a secret, you might need to deploy the admission webhook, and admission webhook will be able to detect any issues. So this is how you define the Alert Manager config. It's the same thing. You have Alert Manager config which you define normally. The same thing you can put in this particular object, and you just need to let's have the selector field. Like we said earlier, there was something like Alert Manager config selector. So you can just define it in the Alert Manager object, which all things to be selected. So you can even merge with so many Alert Manager configs as well. So you can even define it in various namespaces or in the same namespace. So based on which selector you are using, you should be able to pick up those configs. So next is how security is been supported in the operator. So in most of the components we support like a TLS or some even basic auth and OAuth as well. So based on what you want to use, you should be able to use that particular config. So in this example, in the service monitor, we have in endpoints field we have like TLS config. So where you can specify which key to use or which CA to use, like that. If this is the manual way, so if you don't have a CA here, so you might need to do the insecure skip validation. But if you have already a CA running in your cluster, you should be and a cert manager running, you should be able to configure it using that as well. And the next is RemoteWrite. So RemoteWrite is to collect and collect the stream of the matrices, and you can send it to the RemoteWrite endpoint. So it could be like Thanos, Cortex, or anything which can accept the RemoteWrite data. So we mostly use this for long-term storage or any metrics exploration for like doing some kind of analytics. So in Prometheus operator, you have in Prometheus resource, you have a field called RemoteWrite, where you can specify all the RemoteWrite related configs and the URL and also the QConfig, which is used for performance tuning your RemoteWrite, and also you can specify any protection. If you have enabled the protection for the RemoteWrite, you can specify all the details as well. So now we have talked about the features of operator and everything. So how to deploy this in your cluster? So there is like in the beginning I said, there are the two main projects. One is Prometheus Operator and Kubernetes. So Kubernetes actually helps you to deploy a monitoring stack out of the box. So it will already have a Prometheus Operator, Prometheus, Alert Manager. All these configs will be already created, and you can just go ahead and deploy all those manifests. And you will have the already inbuilt dashboards as well, which is done using Kubernetes mixins. If it is a library, also you can use. So if you want to customize your stack, you can just use the Kubernetes as a library, and you will be able to update the JSONet file, and you should be able to create the new config manifest file, and you should be able to deploy that. So this is actually based on a JSONet, because as a data templating language, we can use to define the JSONet document. So it's a bit tricky. JSONet is very much tricky. Whoever has used it might know. So if you are interested, you can use that. So we do have examples in the repo in the Kubernetes, the customization examples. So now let's see what are the limitations for the operator. So it actually hides certain complexity from the user. Mostly like when something goes wrong, it finds difficulty for the users to identify, okay, where my problem is. And it's an opinionated operator, so you can decide if you wanted to deploy it using that, but we do have a lot of people using this. That's why we have like 8K stars. And scaling is one of the issue. If you have a lot of targets, it's kind of difficult to be monitored by the one Prometheus instance. So the sharding support we have is like you can only divide the targets between different shards. For example, if I have a sharding enabled, if I am specifying like 2 replicas, one replica will be monitoring half of your targets, and the another will be monitoring the other half of your targets. So what happens is, if you delete one Prometheus, you will be losing the data as well. So that is one of the limitation. I think once the Prometheus agent is if you are having only RemoteWrite use case, we might be able to use a Prometheus agent there, because there you will be able to automatically scale in case of Prometheus agent. And release for Prometheus operator is a little bit slow, not slow in the case like if you have any new features in the Prometheus, it will take some time to get it updated in the Prometheus operator. So we definitely need help from people in the community. So if you are having any need for any feature, please contribute in the operator so that it will be available in the release soon. So that's all. So we discussed about the operator pattern, and we talked about the Prometheus operator and its features and the various CRDs available, and also some of the common features like how security to be enabled, how to do remote write, yeah, and also some of the limitations and the new features also we discussed earlier. Okay, so if you are interested in contributing, please visit our GitHub page. So you can find a lot of issues. Some will be good first issues. So any new contributors are welcome to contribute. So even if it is not code, you can help us to do some documentation or write some tutorials. And even triaging is a very good thing to start. If you see some issues, you can go and debug yourself and try to see what the problem is. Yeah, thank you.